Hello friends, welcome back to All About Structural Analysis and Design. So this will be the second part of our new series which we have just started, that is IS 456-2000 explanation series. So let's begin with today's video. So before starting this video, if you have found the content of my channel very useful for you, you can just subscribe this channel, and also don't forget to like this video, and don't forget to share this video among your friends circle. So let's begin with today's video. So the last part we had stopped before the 5.3 point. So the 5.3, it says all about aggregates. So aggregates shall comply with the requirements of IS 383. So IS 383 is nothing but the code which is exclusively made for the aggregates, that is testing and all is given in IS 383. So as far as possible, preference shall be given to natural aggregates. So nowadays there are again different types of man-made aggregates also, but as far as possible for the reinforced cement concrete, you have to give the preference for the natural aggregates as per IS 456-2000. Then 5.3.1, it says other type of aggregates such as slag and crushed over burnt brick or tile, which may be found suitable with regard to strength, durability of concrete and freedom from harmful effects, may be used for plain concrete members. But such aggregates should not contain more than 0.5% of sulfates as SO3, and should not absorb more than 10% of their own mass of water. So nowadays we are using the other type of aggregates such as slag and crushed overburnt brick or tile they have given. So the waste products which we get, we are adding, but you can add those, but you have to remember such aggregate should not contain 0.5% of sulfates and should not absorb more than 10% of their own mass of water. And 5.3.2 says heavyweight aggregates or lightweight aggregates such as bloated clay aggregates and sintered fly ash aggregates may also be used, provided the engineer in charge is satisfied with the data on the properties of concrete made with them. So you can go with these type of heavy aggregates and lightweight aggregates, but the engineer who is in charge of that particular project should approve that one only if the properties of concrete made with them are satisfied. So they have given one note here: some of the provisions of the code would require modifications when these aggregates are used. So therefore you have to refer the literature of that particular special concept, and you have to consult it with engineer for the guidance. So before using anything other than the natural aggregates, you have to be careful, and you have to follow the procedure and the limitations of that particular aggregates. Then 5.3.3, it says about size of aggregates. The nominal maximum size of coarse aggregates should be as large as possible within the limits specified, but in no case greater than 1/4 of the minimum thickness of the member, provided that the concrete can be placed without difficulty so as to surround all the reinforcement thoroughly and fill the corners of the form. For most of the work, 20 mm aggregate is suitable. So in the normal works which you will be seeing while casting the footing, columns and all, the majority of the aggregates will be of 20 mm size. But where there is no restriction of the flow of the concrete into sections, 40 mm or larger size may be permitted. So when there is no restriction of reinforcement, for example, if you say, so you can that time use the aggregates which are about 40 mm or larger than 40 mm. In concrete elements with thin sections, okay, so this is important, in concrete elements with thin section, closely spaced reinforcement, or if you are providing small cover, considerations should be given to the use of 10 mm nominal maximum size. So if you have the column which is having a thin section, or a beam which is having thin section, where you cannot go for 20 mm size aggregate, that time you have to use the smaller aggregates, and you can limit it to 10 mm for the use. So it depends upon the work, which type of work you are handling, and depending upon the work and the reinforcement criteria, you can just use the aggregates with respect to these conditions. So plumps above 160 mm. So before explaining this, I would like to say that plumb is nothing but the boulders or big size stones which usually sizes between 160 mm to 300 mm. So plumps is nothing but the big boulders or big size stones. So plumps above plumps above 160 mm and up to any reasonable size may be used in plain concrete up to a maximum limit of 20% by volume of concrete. So you can use the maximum about 20% when the plumps have been used for the plain concrete work, it says, because it is impossible for using for reinforcement concrete, because 160 mm size is too big to provide in the RCC structures. When specifically, so that too when specifically permitted by the engineer in charge, that time you can provide the plumps. And the plumps shall be distributed evenly and shall not be closer than 150 mm from the surface. This also you have to remember. And next point is, for heavily reinforced concrete members, as in case of ribs of main beams, the nominal maximum size of the aggregates should usually be restricted to 5 mm, less than the minimum clear distance between the main bars, or 5 mm less than the minimum cover to the reinforcement, or whichever is smaller. So as we have discussed in the above point, depending on the conditions, there are some cases you have to provide heavily reinforced sections. That time what you have to do, heavily reinforced sections means the spacing between the bars will be very low, and that time 20 mm is not also feasible to provide, not even 10 mm. So that time you have to restrict it to 5 mm. If the spacing is 10 mm, if you say, so the aggregate size should be 5 mm. Okay, so like this we have to provide, or 5 mm less than the minimum cover to the reinforcement. So whatever you are providing the cover for the reinforcement, so 5 mm less of that particular value it should be taken, or whichever is smaller between the two you have to select it. So like this way you have to remember the size of aggregates, how to use. And coarse and fine aggregates, that is sand and coarse aggregates, shall be batched separately, and all in aggregate may be used only where specifically permitted by the engineer in charge of that particular project. So this was whole thing about aggregates, what is the nominal size, and with respect to the project which type you have to use. And next is the quality of water. So water used for mixing and curing. So you know that concrete is impossible without the mixture of water. So it is very important ingredient, and lot of care should be taken when you want to produce a quality concrete. So water used for mixing and curing shall be clean and free from injurious amounts of oils, acids, alkalis, salts, sugar, organic materials, or any other substances that may be deleterious to the concrete or steel. So as you know that concrete, reinforced concrete is a composite material, so you should take care that the water which you are adding for mixing the concrete and curing, it should not be harmful to the concrete as well as the inner steel. And the potable water is generally considered satisfactory for mixing concrete, and as a guide the following concentrations represent the maximum permissible values. So they have given the two guidelines here. If you want to neutralize the 100 ml sample of water using phenolphthalein as an indicator, it should not require more than 5 ml of 0.02 normal NaOH, and the details are given in IS 3025 part 22. Similarly, again second guideline they have given is, again if you take 100 ml sample of water to neutralize, using mixed indicator. This time it should not require more than 25 ml of 0.02 normal H2SO4, and this is also given in IS 3025 part 23. And the permissible limits for solids, so the solid matter which can be permitted is given in table number 1, which we will see in some minutes. Then 5.4.1, in case of doubt regarding the development of strength, the suitability of water for making concrete shall be ascertained by the compressive strength and initial setting time tests, which is specified in the next coming points. Okay. The sample of water taken for testing shall represent the water proposed to be used for concreting. So it is not like that the water which you are testing is not used for actual making of concrete. So whatever you are using the water, it should be tested, and the same water it should be used for concreting purpose. The meaning of that 5.4.1 paragraph. The water should not receive any treatment, okay, before testing, and the regular supply of water proposed for the use in concrete. So before using the water should not be treated before going for the testing, and the sample should be stored in a clean container previously rinsed out with the similar water. So wherever you are storing the water, so that particular vessel should be cleaned with the similar type of water or with the same water. And 5.4.1.2 says average 28 days compressive strength of at least 3 150 mm concrete cubes prepared with water proposed. So you have to produce at least 3 concrete cubes of your standard size, that is 150 mm into 150 mm into 150 mm, which might you have seen in your material testing lab also. So you have to make the concrete with that same water, and you have to produce 3 cubes, and it shall not be less than, the values of that 3 cubes shall not be less than 90% of the average strength of the cubes prepared with distilled water. So you have to make the different sets of concrete cubes. The first one will be the actual water which you are going to use, that you have to cast, and the next set of cubes you have to cast with distilled water, and the values which you get with the water which you will be using shall not be less than 90% of the cubes which have been made with the distilled water. Okay. And the initial setting time of test block made with appropriate cement and the water proposed, so whatever you are going to use that water to be used, shall not be less than 30 minutes and shall not differ by plus or minus 30 minutes from the initial setting time of that test block prepared with the same cement and distilled water. So again, the initial setting time also you have to check with the water which you are going to use and with the distilled water, and it should not be less than 30 minutes and it should not differ by plus or minus 30 minutes when you compare both the values. And the test blocks shall be prepared and tested in accordance with the requirements of the IS code IS 4031 part 5. And one more thing you have to remember is the pH value of the water shall not be less than 6. So the water should not be used when the pH of water is less than 6. So these are the things you have to remember. And one more point they have given is the seawater. So as you know that seawater is having a lots of salts, so usually it is avoided for RCC structures. So the mixing or curing of concrete with seawater is not recommended because of presence of harmful salts. But if the condition is unavoidable and if you want to use seawater, then the mixing or curing in plain concrete with no embedded steel, after having given due consideration to possible disadvantages and precautions, included use of appropriate cement system. So the first thing it says is it should not be used for RCC, and even though if you want to use, it should not have the steel bars into that concrete. So it means you can use it for normal concrete. This was the table 1 which I had mentioned above, the permissible limit for solids. So if the organic matter is present, the permissible limit is 200 milligrams per liter, and if it is inorganic, 3000 milligrams per liter. And if sulfates are present, maximum limit is 400 milligrams per liter. Chlorides 2000 milligrams per liter. For concrete not containing embedded steel, and 500 milligram per liter for reinforced concrete work. So this is the value for chlorides. And suspended matter again 2000 milligram per liter. So for chlorides there are two different values for normal concrete and RCC concrete work. So if you are going to use for RCC, it should be less than 500 milligrams per liter, and for normal concrete without steel 200 milligrams per liter. And these are the values and tested as per IS 3025 different parts. So you can go through those IS codes and you can study more about those codes. And 5.4.4 is water found satisfactory for mixing is also suitable for curing of concrete. So if it is suitable for mixing, therefore it is suitable for curing. So however, if the water used for curing should not produce any stains and rough patches on the concrete surface, the presence of tannic acid or iron compounds is objectionable if the water which you are using for curing. So before that one you have to test it. Then the next 5.5 point is for admixtures. So it should comply with IS 9103. Previous experience and data, if it is there on such material, should be considered. Then admixture should not impair durability of concrete. So it should not have adverse effect on your concrete and constitute to form harmful compounds after mixing with the concrete. The workability, compressive strength and slump loss of concrete with and without the use of admixtures shall be established during trial mixes before use of admixtures. So if you want to use the admixtures, you have to test the workability, compressive strength and slump loss of concrete with and without use. So directly you cannot use the admixtures. First you have to test it without admixtures, then you have to test with the admixtures. Then relative density of liquid admixture shall be checked. Okay, and if it is between specified value, then it is accepted. The chloride content of admixture shall be independently tested for each batch before acceptance. So as you have seen the quality of water here, the chloride content is very important for reinforced concrete work. It should be less than 500 milligram per liter. So it should be tested for admixtures also. And if two or more admixtures are used simultaneously in the same concrete mix, data should be obtained to assess their interaction and to ensure their compatibility. So if you are using two admixtures, you have to see that whether the two admixtures are compatible with each other or no, and also you have to interact the values of that particular admixtures before using two admixtures in the same mix. And next is the last point of this fifth point of this IS 456 is reinforcement. And any of the reinforcement can be used, that is mild steel and medium tensile, high strength deformed, hard drawn steel wire fabric conforming to IS 1566, then structural steel conforming to grade A of IS 2062. So these are the steels you can use. And all reinforcements shall be free from loose materials, loose rust and coats of paints. So everything it should be clean. Then special precautions like coating of reinforcement may be required for reinforced concrete elements in exceptional cases. For special structures and all, you read the coating for the reinforcement, which is again the new method to protect the steel from getting corroded. So you can use those things. And for the special structures, special literature means what you can say is the research papers on all, you can have a look about that particular coating of reinforcement. And the modulus of elasticity of steel shall be taken as 200 kilonewton per mm square, and the characteristic yield strength of different steel shall be assumed as the minimum yield stress, that is 0.2% proof stress specified in the relevant Indian standards. And the storage of material shall be described in IS 4082. So nothing detail is given how to store the materials. So different separate code, that is IS 4082, shall give you the guidelines how to store the materials. So that's it for today. So I will be stopping here, and the next part 3 I will continue with the 6th point, that is concrete. So I hope you have liked this video. If you have liked this video, please like it, share it, and don't forget to subscribe all about structural analysis and design. Thank you, friends.